Welcome to the Learning Video Series, Extending Map Suite. In Lesson 1, we'll go over integrating custom data formats. Here you're going to learn the basics of how to integrate your own custom data into Map Suite. My name is David Rehagen, and it's my pleasure to present to you today. Prerequisites. You'll need a working knowledge of object-oriented principles. You should know what a class is, what properties and methods are. You'll also need a basic understanding of inheritance. You'll need to know how to inherit from a particular class. It's also good if you have a familiarity with GIS and Map Suite, and you'll have an advantage if you already understand how a lot of the Map Suite objects fit together. The most important thing is really to do your homework, understand the data format you intend to integrate. We can make it very easy for you to create your own feature sources, but at the end of the day, you're going to need to know how that data is stored, what format it's in, and what are the optimized ways of getting the data in and out. And we can't do that for you. So spend a lot of time, do your homework, and understand your data formats. And then the rest of it, as you'll see, is a piece of cake. Agenda. In this video, we'll first answer the following questions. Why integrate custom data formats? How does Map Suite make things easy? Why is a progressive API important? What are the important classes? What is required for a feature source? What overloads are recommended? And how do I integrate a feature source with a layer? Now, after we answer these questions, we're going to review the code of a working feature source, and we'll go method by method, property by property, and show you how it works. After that, we'll answer any additional questions you have about any of the topics that I covered. So why integrate custom data formats? Now, why should you care about adding your own data, making it integrate well with Map Suite? Well, there's a number of possible scenarios, and this isn't an exhaustive list, but it's what we see day to day. The first one is support for proprietary formats. You may have your data in a format that's proprietary to your company, and you'll want to export that data or use it inside of Map Suite. You need to support existing legacy technologies. Maybe there's a legacy mainframe or a legacy SQL Server installation, and you need to get to that data. Support for new closed and open source formats. There's new GIS formats being created all the time. There's new open source projects and new closed source projects that you'll want to integrate with. And so being able to create your own custom feature sources is going to be a big advantage to you if you want to integrate with those. You might have a dependency on an external data vendor. So you have a dependency on a company that provides you with satellite imagery, or maybe you have to call a web service or a web feature service or something like that, and you're going to need to build your own feature source. Or you might just want to enhance our existing implementation. I mean, I think that we've tried to do a good job on it, but you might take an existing feature source that we have, like Shapefile or SQL Server or Oracle Spatial, and you might be able to enhance it based on your specific needs or your understanding of the underlying data. There's optimizations that you could make if you know your data that we could have never guessed. So that's another important part. And the last one is to support distributed data scenarios such as cloud computing. So let's say, for example, that the data that you have isn't in one place, not in one SQL Server. It's across a SQL Server and a little bit in Oracle and a little bit in this cloud somewhere out there that needs to be called to a web service. What you can do is, if you need to aggregate that data together, you can create your own feature source that gives the appearance that it's really homogeneous, where in the back end it's actually going out to different sources, compile that data up. So that's kind of powerful. And as far as the users are concerned, or the way that it displays on the map, they have no idea that it's from all these different places, kind of like a mashup. So moving on, how does Map Suite make things easy for developers who want to integrate their own custom data? Well, the first thing we do is that we provide excellent documentation. And it's important to understand that whenever you're inheriting from an object and you plan to override some of the methods, it's important that you read the documentation to get guidance on what you need to do in those objects. Do you need to call the base after you implement whatever you need to implement? What are you supposed to do in that function? Are there any dependencies that you need to know before you override? And so we do a lot of offering guidance inside the documentation. The second thing is that we eat our own dog food. And if you're not familiar with the phrase, eating your own dog food essentially means that you use your own tools. And so whenever we create, or actually when you see the feature sources that are shipped with MapSuite, such as the SQL 2008, the Oracle Spatial, Shapefile feature source, these classes inherit from feature source just like what we're going to do today. So we use the same tools and the same methodology that you're going to be using. The difference is, and what we're trying to do with this video is now just to educate you, to show you how to do it. So we eat our own dog food. The next one is rich IntelliSense. So for all of our properties and methods, for each of the overloads, try to give you a hint on every property and every method, and even the parameters on what these properties are supposed to do, what these methods are supposed to do, what these properties mean. And so it's really important, and it's going to help you immensely. The fourth is that we have a professional discussion forums. And what I mean by that is that when you ask questions on the discussion forums, they get answered. So it's not just the community discussion forums where your questions getting answered by the community. We actually have people on staff that go into the discussion forums and make sure that people get the help that they need. So, I would definitely invite you when you're trying to implement your own feature source, go in the discussion forums, ask questions, post code. We're here to help you with that. The last, but maybe the most important, is that we provide a progressive API. We'll go into that on the next slide, but it's a good thing, and that's definitely what you want. And more on that in just a second. So as you can see, we do a lot of things to make things simple, and you'll see really how simple they are here in just a few minutes. Let's talk about progressive APIs and why they're important. In a nutshell, a progressive API is an API where the coding effort rises in step with the complexity. So that means that the easy tasks can be accomplished easily. As the complexity of the task starts to increase, you have to do a moderately more amount of code. So they're kind of in step. As the requirements get a little bit more difficult, you have to write a little bit more code, or the code that you write gets a little bit more difficult. And on the very high end of difficulty, the most difficult tasks are at least possible. And a good analog for this is if you look at, if you guys are familiar with Visual Basic 6. Well, Visual Basic 6 was really great. It wasn't a progressive API. What do I mean by that? What I mean is that the easy things in VB6 were very easy, and even some of the moderately hard things were very easy. But you got to a point where it just fundamentally let you down, where you wanted to do something a little bit harder, but you just couldn't do it because the APIs didn't support it. And so what you were forced to do then is go to another tool such as C++ or Delphi where the APIs were a little bit more progressive and allowed you to do the more difficult stuff. So the reason that a progressive API is important is that it won't let you down in the future. It'll allow the easy things to be easy, the more moderately difficult things to be just a little bit more difficult, and then if you have a case that's really, really difficult, yeah, it might be difficult to code, but it's at least possible. And so when you're making an investment, you want to invest in a platform that you know isn't going to let you down in the future, no matter how complex your requirements become. So that's what a progressive API is in a nutshell, and that's why it's so important. Now we're starting to get into the meat and potatoes of the course. And let's talk about what are the important classes when you want to integrate your own data. One of the core classes is feature. Now, feature is the basic unit of a geometric object, which means, let's say, for example, you have an Oracle Spatial system, and there are 10 polygons in the table, then each one of those polygons would be equivalent to one of our features. And a feature has a unique ID. You can see how that's important. You need to be able to tell these different features apart. The other thing is that the feature can contain column data that describes it. So going back to the Oracle spatial analogy, of course, one of your columns is going to hold the data for the geometry itself. And then you can have additional columns that might be what's the name of the feature or some different attributes of the feature. So just think of feature as the main currency in our system. You're moving features around all the time. And that leads to the next one, a feature source. So you can kind of see the connection. Feature sources provide features. So the feature source is an abstract class, and it abstracts the underlying data source. So for example, if I want to integrate, let's say, some data that I have in Access, then I'm going to create an Access feature source. And the feature source is going to look the same on the outside, but on the inside, it's going to have all the important knowledge about how to go into Access and how to get this data, and then it's going to format it for consumption in the rest of our framework. A feature source provides a spatial querying capability. So that's where the feature source is where you can go to it and you can say, give me all of your features that are inside this bounding box, or give me the feature that's nearest to this point. It also provides those kind of features. And the feature source is also responsible for editing. So if you want to add new features to the feature source, delete, or edit them. In this particular video, we're not going to get very much into editing, but we will have a follow-up video to explain how to add editing to your feature source. So in this video, we're going to really focus on read-only feature sources just because of time constraints. The third, and maybe one of the least important, is actually the feature layer. And it's not that it's unimportant in the whole scheme of things, but it's a little less important for the inheritance. And what a feature layer does is that it wraps a feature source. Now, think back to when we talked about feature sources a second ago, and that the feature source abstracts the underlying data. Well, what the feature layer does is it has a feature source inside of it, and the feature layer exposes all of the different kind of rendering-centric APIs. Like for example, a feature layer is going to have your zoom level set. It's going to have your styles. It's going to have those kind of things on it. So in essence, you can kind of picture this in your mind, that the feature source is kind of what you're analogous to, like a data source, and then the feature layer is the thing that consumes it. So you can kind of think of a feature source always being embedded inside of a feature layer.